Okay, so today we are really going to talk about the unit circle again, and what we want to do is figure out these numbers that I have here. So let me go ahead and back up. The unit circle is called the unit circle because it has a radius of 1. So if I were to graph it on graph paper, it's this little itty-bitty circle, right? And then on this little itty-bitty circle, since it's on graph paper, you're going to have some coordinates. Well, you're going to have a coordinate here at 1, 0, 0, 1, negative 1, 0, and 0, 1. Now, on our circle yesterday, we put all these other angles in. We put the 30 degrees, 40, the 60, and all these angles. But then they also have coordinates on the graph. This is way too little. So what we do is we expanded it and made it big enough to fit on the sheet of paper. So this circle is really this circle, except for we wanted to make it much bigger. So we've got our coordinates 1, 0, 0, negative 1, 0, 1, negative 1, 0, and 0, negative 1, okay? We put all our angles in. We have our radians in as well as our degrees. Now, how do we get these other coordinates? Well, we've got to go back to geometry. So if I go back to geometry, if I were to create a 45, 45, 90 triangle, if the radius is 1, then this side becomes square root of 2 over 2, and this side becomes square root of 2 over 2, okay? Those are the exact values. If that's the case, then if I had to make a point, and a coordinate of a point would be x, y. The x value would be square root of 2 over 2, and the y value would also be a square root of 2 over 2. If I wanted to create a 30-degree angle, if this side was 1 from our special right triangles, then this side turns out to be square root of 3 over 2. This side turns out to be 1/2. The coordinate of this point then would be square root of 3 over 2 and 1/2. Finally, if I had a 30-degree angle, 60-degree angle, 30, this side would be the square root of 3 over 2, and this side would be 1/2 if the radius is 1. So all of these triangles actually exist on my unit circle. We just don't see them. So if we're going to trace them out, first of all, I'll just show you. Here is a 30, 60, 90 triangle. And we know from my picture that this would be square root of 3 over 2. This would be 1/2. So my coordinate is square root of 3 over 2. That's my x value. My y value is 1/2. So the coordinate of this point is square root of 3 over 2. My 45, 45, 90 triangle is also there. Okay? Not very straight, but that's a 45, 45, 90 triangle. Again, from our warm-up, we find the coordinate of that is at square root of 2 over 2. And so I have the coordinate square root of 2 over 2, square root of 2 over 2, so the coordinate of the point is square root of 2 over 2. Now the 30, 60, 90 triangle is just a 60, 30, 90 triangle, just standing up tall. So its coordinates would be just the opposite. It would have a 1/2 and a square root of 3 over 2, and we actually did that one there, 1/2 square root of 3 over 2. Okay, so we get its coordinate to be at 1/2 square root of 3 over 2. So what we did in class is we put all of those coordinates in, and then what we recognize is that on the other side of the triangle it's just a reflection of those. So instead of 1/2 square root of 3 over 2, it's back, so it would be a negative 1/2 square root of 3 over 2. Instead of square root of 2 over 2, it's a reflection, so it would be a negative 1/2 square root of 2 over 2. And then on the 30, 60, it's a reflection over, so instead of square root of 3 over 2, it would be a negative square root of 3 over 2, 1/2. And then, of course, the triangle reflects all the way around. We get all of these triangles reflect. Quadrant 3, we have to go back and down, so everything's negative in quadrant 3. Quadrant 4 is going to be over and down, so your x values will be positive and your y values have to be negative because you go over and then down. Let's put that. In fact, you guys sitting in the audience, let's do that real quick. Let's make sure we know this is quadrant 1, right? This is quadrant 2, right? This is quadrant 3. Whoops, 3. I said 3 and wrote 4. Darn me. And quadrant 4. Okay, everybody good on that? Pretty simple. Because we'll talk about the importance of that. What we know is this: everything's positive in quadrant 1, right? Everything is positive in quadrant 1. In quadrant 2, the x's are negative, so the y values are positive. So sine is positive. All the sine values are positive in quadrant 2, aren't they? Okay. Quadrant 3, x and y's are negative, but the tangents are positive. in quadrant 3, right? Because the negative divided by negative. And in quadrant 4, we know that the x is positive and the y is negative, so we have positive x is negative y. So the cosine values are positive in quadrant 4. It actually makes sense, right? Now, we also know that when we take a look at doing sine, cosine, and tangent, that we know sine is opposite of hypotenuse. Sine is opposite of hypotenuse, so sine just turns out to be the y values. We know cosine is going to be the adjacent over hypotenuse, so the cosine is the x over 1, or it's just the x values. And the tangent values are the y values over the x values, so it's just the y over the x, okay? Now, if we apply that to the unit circle, if I'm going too fast, you guys can always push pause and wait a while, but everybody else in class is already there with me, right? So if that's the case, see how easy this is. You ready? Sine of 60 degrees. Sine is the y value. The exact answer is the square root of 3 over 2. Cosine of 135. Cosine is the x values. The exact answer is negative square root of 2 over 2. Now you can use a calculator. You can get a decimal answer equivalent, but that's not going to be good enough. I want the exact answer. I want the negative square root of 2 over 2. I can do the tangents. Now the thing about the tangents is we wrote the tangents in because if you go straight to square root of 2 over 2, square root of 2 over 2, that is a 1. So I wrote the tangent values after simplifying them in class, but all the tangent values on the outside in red. You can see all my tangent values. So if you need to pause this video, you can, and you can add in the tangents. We already got them. In class, we got them done, right? Okay, now, if we take what we know and apply it to our worksheet, let's do this. So now, Common Core Center Day is finding trig values from the unit circle. Okay, somebody could ask me, well, gosh, Mr. Davis, if I can do it in my calculator, why do I need that stinking unit circle? Okay, there's a couple of good reasons later on in the week, but the answer I'm going to give you right now is because you won't be able to give me exact answers. You're never going to be able to give me a negative square root of 3 over 2 from your calculator, right? It won't give you that. But we can get it. We can get these answers faster than our calculator and more accurate. Okay, check it out. I am recording, yeah. So you ready? Sine of 150 degrees. Okay, sine is the y value. Sine is the y value. That's a y, really. Sine is the y value, right? 150 degrees is there. The y value is 1/2. That's the answer. You can check it on the calculator if you want to, but it is 1/2. Cosine, 2 pi thirds. Cosine is the x value. Okay, so I got a 2 pi thirds on my unit circle. 2 pi thirds is here. Cosine is the x value. It is negative 1/2. Again, you can check that on the calculator if you want to, but you'd have to change it to radian mode first of all, wouldn't you? To even make it work. But by the time you did that and push your buttons, I already got it done. Okay. Tangent 300. Now, tangent's the y over the x, but luckily for us, we put our tangent values on the circle, 300 degrees. The tangent value is negative square root of 3. So two things. One, you'll never get this answer on your calculator because it's a square root answer. And two, I can do it faster. Negative square root of 3. Okay? Sine of negative pi force. Now, you ready? We're going to go backwards on a circle. If a rotation of pi force, here's pi force, is here, then a negative pi force would rotate backwards to here, right? So that's pi force. This is a negative pi force, right? Think about that. It's going backwards. And if I want the sine, which is the y value, it's going to be a negative square root of 2 over 2. You want me to do that again? Okay. Pi force is here. If I want a negative pi force, negative pi force is here. That's a negative pi 6. That's a negative pi thirds, and that's a negative pi half. So I'll just put that in my unit circle to help me out later, okay? So negative pi force is here, negative square root of 2 over 2, okay? Boom. Negative square root of 2 over 2, because it's the y value, okay? Cosine of negative 90, okay? So if 90 degrees is here, negative 90 degrees, rotate backwards here. Cosine is the x value, 0. Cosine is 0, okay. Tangent of 90, okay. So, all right, tangent's the y over the x, so let's see, 90 is here. Cookie Monster's sad because it's the 1 divided by 0. You can't divide by 0, but we already know it's undefined. I use the word empty set, but technically we're going to write undefined, okay. It's a domain error, and we're going to see it when we graph it. It's an asymptote. When we graph it, we're going to see it's an asymptote, okay? Sine of pi. Sine is the y value, right? Go to our pi on our circle. Sine is the y value. Boom, it's just going to be 0, okay? Okay, cosine of 450. Whoa, what in the world is that? Well, let's take a trip. Okay, you ready? Everybody watching? Watch my finger. I'm going around. 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 360 degrees, right? I got to go 450, right? So I go another 90 because, you ready? 360 plus 90 is 450. You guys agree with that? So let's find the x value at 90. 0. Okay. Okay, now, tangent of negative 2 pi thirds, okay? So, positive 2 pi thirds is a rotation to here, right, to 120 degrees, with me? So if I want to go negative 120 degrees, I'm just going to rotate backwards to there, right? And I'll show you a trick on doing these in a second, okay? So if you can't rotate, I'm going to show you how to do it without rotating, okay? So then, what is my tangent value? Square root of 3. Okay, square root of 3, okay? Now, if you have a hard time with these negative angles, okay, I'm going to show you another way to do it, okay? So I know 2 pi thirds is an equivalent of 120 degrees, right? So that's the same thing as tangent of negative 120 degrees, okay? You okay with that? You okay with that? Say 2 pi thirds is 120, okay? So if I had to take 360 minus 120, I get 240. So I can go straight to tangent to 240, which is where I was at, right? It was where I was at, right? Square root of 3, okay? Now, all of a sudden, we're going to go and take ourselves off the unit circle, okay? So here's what we know. If we want to find the arc length, so the arc length is S equals R theta, okay? There's a formula for arc length. S stands for arc length. S is arc length. Okay? Theta is my angle, but the problem is the angle's in radians, and that's why we like radians, because the arc length and the radius and the angle are all related. Of course, r is the radius, okay? So we're going to go one big bummer. 50 degrees. It's in stinking dumb degrees, okay? So to use this formula, we got to convert. We got to convert 50 degrees into radians. Okay? Okay, remember we did that yesterday? Okay, how do we convert? We've got a little formula for converting, right? So we're going to go 50 over 180 times pi. That was our little conversion we did yesterday. Remember a little conversion? So I need to change my angle into radians because this formula will not work unless it's radius. So let's go ahead and I'm just going to use a calculator because we want an arc length, right?
Does the formula mean you're dividing it by 180 to get rid of the 180, but pi equals 180, so you just multiply it by pi?
Smart girl. Yes, because it's an equivalent, right? Because you have this equivalent right at the bat that in radians, pi is equal to 180, and that's why it is exactly.
Yeah.
Exactly. So, nice job, Claire. So if I did my 50 divided by 180 times my pi, finally get math Claire appreciates. So it's about 0.87. Now that is an angle. That doesn't look like an angle. It's like, Mr. Davies, don't fool me. 0.87 is not an angle. Yes, it is. It's an angle in radians. Remember, 1 radian is about 57 degrees. Remember we talked about that? 1 is about 57. That is an angle. In fact, that's a 50-degree angle, but it's in radians. Okay, so my theta then here is about 0.87. .8726, blah, 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 approximately equal to, okay? So I'm just going to use my calculator. The arc length is S is going to equal to my 5 times my angle, 0.8726, blah, blah, blah. And I'm going to go, then I'm going to take this answer, I'm going to go 5 times that answer, and I get about 4.36. Pretty handy, isn't it? Pretty handy. And it's a great illustration of how radians are completely connected to the angle, right? Yes, Katie.
Can you explain how you got to 5 again?
Sure, it's right there. That's easy. What's the radius? It's all good. Look, Katie, I do not mind doing that. You know that, right? Okay, so we have a worksheet, and it should be easy, okay?